Good morning, Bears. I have got my Cardinals hat on today as we kick off Metabolism. My metabolism was on fire in that Cardinal game. Great catch. I happen to be an Arizona Cardinal fan. I grew up in Arizona, went to college at Arizona State, saw the Cardinals when they were called the Phoenix Cardinals in Sun Devil Stadium before they had their own stadium. And I'm also a little bit of a Ram fan, which some people think you're not supposed to be both, but I am. But Chargers is the second favorite team, and they're not doing well, but this is the year of the Cardinals. All right, let's get to Metabolism week number 3, lesson 8 through 10. We are diving into Metabolism once again, and we're going to do some body work today, some stuff you may have done in your PE classes, because guess what? When we study about the human body, we've got one right there with us all the time, your own. And so we can analyze our breathing in through the nose, hold it, out through the mouth, in through the nose, hold it, out through the mouth. Oh man, if you do that, you can just feel yourself calm down, and you're taking extra oxygen into your body. And as we saw from our sims, we can see how oxygen goes into the body and feeds the body with energy. So we're diving into some of that today, and we're going to analyze some questions and some answers about why does Alyssa with her diabetes. We know she has diabetes, and that's a problem with energy and sugar, but we're going to see if we can predict and then do some investigating on what exactly goes on in the body. So as usual, I have an outline for you here, how to write a CER, how to use the fist format for grabbing readers. That's my concept, because you always have your hand with you. Beginning, middle, end, details there. Check that slide when we start our writing this week. Here, I have to change this right now. Hold on, let me change it. Let me just check that out. Change there, it just said week 1. This is actually week 3, but it just reminds you to check groups for your Mandy's. Those are the daily activities. Zoom class is the best place to be, but if you miss it, you can watch this video and go through the activities. Let's get started. So Alyssa was feeling extremely tired, and based on the analysis she did, we now know that she has diabetes, a condition that prevents glucose from entering the cells in her body. Why would having low glucose in her cells make her feel tired? What do the molecules in your cells have to do with your energy level? That's what we will be investigating next. You do not need to answer these now. We will answer them later. In this chapter, we will focus on gathering evidence to answer this question: how do molecules in the cells of the body release energy? Today, we will investigate this question: which molecules do the cells need to release energy? So before we start, let's do a little guessing game, a little hypothesis. Hypothesis is kind of like a guess, but it's more of an educated guess. So here's some possible claims that could answer our investigation question. Which claim do you think is most accurate? So let's read through these. If you're in Zoom today, I want you to place your answer into the chat box. And you can do that either by copying and pasting this off your own slideshow, because you have access to this slideshow, or let's just say we can put 1, 2, 3, 4, 5, or 6. Place it in the chat. Remember, these activities count towards your history grade this week, getting information from places, the history type skills. And so you need to make sure you put this in the chat and participate. If you are at home, you may just put it in this box right here. Now you can do both. If you want, put it in the box and in the chat, people that are in Zoom. As a matter of fact, let's do both so we have an easy record in both places. So right now, let's read them. This is just a guess based on our research. Claim 1, cells need glucose to release energy. So which molecules do cells need to release energy? Glucose. Cells need glucose to release energy. Is that true? Claim 2, cells need amino acids to release energy. Claim 3, cells need oxygen to release energy. Claim 4, cells need glucose and amino acids to release energy. Claim 5, cells need glucose and oxygen to release energy. So we're talking about cells and these different molecules that we have studied. Or claim 6, cells need all 3 types of molecules to release energy. So right now, just write the number in the chat. Take a look, take a second, think about what you know. Which one do you think it is? 1, 2, 3, 4, 5, or 6? This is on the screen, in the chat room, or here on the slide if you're doing this at home. Go ahead and do that now. You have 1 minute to think about it and place it. Back, you should have one of these in the text. Let's look at some of our responses. If we're live in Zoom, we'll check those out. And remember, we don't know for sure. We're going to research it. What is the best claim? And you can probably guess what you're going to do later once we know that claim. Now let's continue on and see what's next. We'll be gathering evidence today to help figure out which claim is best supported. We'll start by observing what happens in our bodies when we increase our activity level by running in place. Since movement requires energy, we can see what happens to the body when it uses more energy. You will observe your heart rate and breath rate before and after you run in place. Heart rate is the number of heartbeats in a certain amount of time, and breath rate is the number of breaths taken in a certain amount of time. What could changes to your heart rate and breath rate tell you about what is going on inside your body? So we don't need to answer that there. Let's just share on Zoom. If you're in class, if you're watching this on video, just think about it for a second. What could changes to your heart rate, going lower heart rate, higher heart rate, or breath rate, breathing faster or slower, what could that tell you about what's going on in your body? Think about that for a second. Okay? And then let's get to our experiment. A change to heart rate could mean the blood is pumping faster or more slowly through the body because cells need more or fewer molecules. And remember, oxygen is a molecule. A change to breath rate could mean that the body is taking in more or less oxygen from the air. And remember, the blood carries oxygen and other molecules. The breath takes oxygen mainly that we use. It does take other molecules, but the oxygen is the main thing that we use. So a change in breath rate could mean the body is taking in more or less oxygen from the air. We have our breathing and we have our heart. So practice observing your heart rate. Before we get to this, I think it's more fun to take a little video tour. So let's watch this video. And remember, these videos are also in the link in groups. If it's not working, you can watch it later. How to feel your heartbeat. Here we go.
Hi guys, do you want to try something neat? Take these two fingers, now hold them on the side of your neck, right next to your throat. If you hold them still for just a moment, you'll start to feel something bumping around in there. That is your pulse, the feeling of blood moving through your body. And that means you're actually feeling your heart beating. Your heart is always beating, all day and all night, even when you're asleep. It can never take a break because it has a very important job. It moves your blood all around your body. And your heart can do that because it's actually a muscle. You have muscles all over your body that help you move, like muscles in your legs that you can use to run and muscles in your jaw for chewing yummy food. But your heart is the hardest working muscle of them all. Now make a fist with your hand. That's about how big your heart is. It may seem kind of small, but it's incredibly strong, and it's the constant squeezing of your heart muscle that keeps all that blood flowing. But why does your blood have to move around in the first place? Well, you can think of your blood as working kind of like a delivery truck. It carries lots of what your body needs in order to keep going, especially oxygen. You've probably heard of it before. Oxygen is the gas in the air that people and a lot of other animals need to live. When you breathe in, you're bringing oxygen into your lungs, and your blood is there to soak up all that oxygen and, with the help of your heart, send it all over your body, to your head and to your feet and everywhere in between. As your blood gets pumped around, all of the different parts of your body take the oxygen from it, and they use it to do their jobs, whether that's making your leg muscles move so you can run or helping your stomach take care of that sandwich you had for lunch. But your body also has a bunch of stuff that it needs to get rid of, especially a gas called carbon dioxide. So after your blood drops off its shipment of oxygen, it also picks up that waste and hauls it off. When your blood gets back to your heart, it gets pushed to the lungs once again, where the blood drops off the carbon dioxide and picks up more oxygen. So when you breathe in, you're breathing in oxygen that goes into your blood. And when you breathe out, you're breathing out the carbon dioxide that your body has gotten rid of. Now, it sounds like a long journey, but your heart can pump blood to every part of your body in less than 1 minute. And your heart beats at least 100,000 times every day. So at any point during your day, your heart is sending blood to your lungs and out to the rest of your body and back to your lungs again all at once. That's some serious work. But have you ever noticed your heart beating faster when you've been running around for a while? That's your heart working extra hard. When you're running, jumping, and playing around, your body needs more oxygen and other nutrients to do that extra work. So your heart has to work harder to send all of those good things to the parts of your body that need them, and to get rid of all the extra waste. So the more you exercise your body, the more you exercise your heart. Now, who's up for some jumping jacks to get our hearts beating faster? And if there's something that you'd like to learn more about, just let us know by asking an adult to help you. Leave a comment below or email us at kids@thescishow.com. And we'll see you next time.
All right, fantastic. So let's take a look. Let's get back to make sure we're recording, check our sound. We don't want to mess up like I've done before. All right, let's go back to our slideshow. So this is just giving you what she said in the video. Step 1, place 2 fingers gently on your neck, just under your jaw, or on your wrist. You can do your wrist. I think the neck is better myself. Move your fingers around until you can feel a steady beat. Each beat you will feel is a pulse of blood from one pump of the heart. Isn't that amazing? So you can actually sense what the heart is doing. Heart and breath rate activity. We're basically going to do what was described. First, observe the breath rate by putting a finger under your nose. Observe heart rate by finding your pulse. Then we're going to exercise for 1 minute, and we will time you here. And then we're going to observe it again and see what happened. So let's do this. First, we don't need to do a full minute on the first one. You can kind of get your average down. So first, find your blood, find your heart rate. I feel mine. Two, 3, 4, 5, 6, 7. Okay, do you find it? Let's do the activity. I'm going to put up a timer. And when I say go, just count. And if you do, the reason they like a minute is you can rate it. It's like 60 beats per minute. So let's go ahead and do the full minute. It'll be fun. And then we'll do our activity. Here we go. Here we go. We have a minute timer, so you don't have to think about the clock. All I want you to do is count. Every time you feel that bump, count. Now you have to put a little bit of pressure there. Go ahead and find it and just count. That's all you need to do. How many beats per minute? Ready? Go. Okay. There. Okay. Remember your number. Let's go back and go ahead and put your number. Write it down. Put it into the chat. Whatever your number is, just write it in there. And if you have your slideshow open, you can go ahead and put it in your slide. Mine was about 58. I think I lost a beat or two, but mine was about 58 beats a minute. So now let's do our breath rate. Breath rate's a little trickier, to be honest with you, because you can slow that down. You can't really control your heart rate. If you're holding your breath, your heart's going to keep beating. It will change, but you can't like stop it. Breathing is a little different because, you know, you can hold your breath, you can breathe fast, but naturally just kind of breathe. So let's start our timer again and just do for like 10 seconds. Just see if it's like breath a second or what it is. Here we go. So I only did, I think, 3 or 4 breaths for 10 seconds. If we average that out, 10 seconds is 10 times 6 is 60 seconds. So say I had 3 breaths. I think mine was more like 3 or 4 breaths. So let's say 3 to 4. 3 times 6 is 18. So I would say about 18 to 20 breaths a second for me. I mean, yeah, a minute for me. So you can write that down if you want. You can do that on your own later. Like I said, it's a little bit trickier. So let's get going here and do our next activity. Guess what? We're going to run in place for a minute. Screens on if you can. Jumping jacks work. Hopping works. Little jumping jacks like this works. Running in place works. If you've got room, you can kind of run around your couch. You could even do push-ups. You could do some physical activities like this if you want. Any kind of movement right now. We're going to do that for a minute. So get up out of that chair, get ready, get your Wii on, and let's set the timer. And you're just going to move around, jump around. Even if you're in your seat, if you just did this for a minute, it's going to change it. Ready, get ready to go. Start doing some activity now. Activity time. It's like PE. Go, go, go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Whew, whew. It's tougher than it looks. There's my cat. What's up, Puma? Cat just went by. 10 seconds left. We got this. If you need to slow down a little, that's fine, but just keep moving the whole time. 1 and done. Okay. All right. Go to your heart rate. Get ready. Find it. Here we go. I'm starting it. Count them. Okay. Mine started to slow down. I think I lost count, but I think mine was like 75. So my last one, I can't even remember now. I should have written mine down. I think mine was more like 55. So 20 more beats in a minute for me. So I think mine was 55. They call that a standing heart rate. And then 75 after physical activity. If you got lost or you got confused, you can do this again once we're off Zoom. It's a little easier. One trick is don't look at the clock. Find a clock at home, click it, don't look at it, focus on the counting, and when the beeper goes off, write it down immediately because you're looking at numbers here and it can confuse you. All right, great job. So go ahead and write that down in the chat real quick. So you should have 2 heart rates. Obviously, even if we lost count, it was pretty obvious very quickly. Breathing, we could do that, but it's pretty obvious. I'm breathing faster and harder when I'm running. And the heart rate, as soon as I felt it, I could tell that thing was going faster. So we know that in general, the faster, what happened to your breath rate? It went faster. Which molecule is taken into the body from the air in which we breathe? Let's go ahead and fill these out on your slideshow later. You can come back and do this. If you're working along with me now, you can do that. What happened to your breath rate? Went up. Which molecule is taken into the body from air we breathe? Go ahead and write that down here. Right, oxygen. Oxygen is the molecule there. Why do you think the respiratory system took in more of this molecule when you're running? Why does your breath rate go up? Why do you need more molecules, more oxygen molecules when you're running? You probably noticed that your breath rate increased. The respiratory system took in more oxygen when you were running. The body needed more oxygen molecules to support the energetic activity of running. So when you run more, you're burning energy. You need more oxygen. Wait a minute. We did this one already. Oh, no, this is the heart rate. What happened to your heart rate? As we know, it went up. So you can write that down. What does the increased heart rate tell you about the circulatory system? What does that tell you? Think about it for a second. What is happening faster? Breath goes up, heart rate goes up, and that means, what's going on in your body? That's right, the blood or the heart is pumping more blood through the body. Why do you think the circulatory system was pumping blood faster when you were running? What do you think? You probably noticed that your heart rate increased. The circulatory system was pumping blood faster when you were running to deliver more of the necessary molecules to the cells in your body. Now remember, the circulatory system and the respiratory system deliver oxygen to your cells. The circular system also delivers other molecules. And going back to our claims, that's going to come into play. All right, so we're going to go into the sim, but we're going to do this tomorrow. We're going to dive into our sim. If you want to go to the sim and play with it today, you can, but those are specific tests, and we don't have time today. So you can play with it a little bit. But right now, the goal of the day, the final, all you have to get done today is go back. Now, open your slideshow. If you need to come back to this video, you can. Come in and just answer the questions. So let's review what we need to get done today. We've already answered them, but you need to fill in the blanks now. So let's come through here. What would having low glucose in her cells make her feel tired? Because she doesn't have energy from the glucose. What do the molecules in your cells have to do with your energy level? The cell needs oxygen and glucose for energy, and we're investigating that. We don't need to answer that one. We will not answer this one. This one we made a claim. We don't have to support that claim yet. We've gathered evidence. We did our activity. This is a prediction. You do not have to write anything there. And coming down here, that's our activities. Here's what I want you to fill out. What happened to your breath rate? Make sure you have something there. Which molecule is taken into the body from the air we breathe? We answered that. Make sure you have that filled out. Why do you think the respiratory system took in more of this molecule when you're running? Go ahead and answer that. This is a statement, and then we have the same 3 questions on heart rate, circulatory system, and blood. And you will be done with it today. So no CERs, answering the questions, the blue slides, answer right in the slides themselves. And then what do we always do with our slides? Once you have the answers, move them to the top. So if you have written anything on any slide, move it to the top. So you will have those highlighted. All right, let's get started. I don't know if you'll have time left or not. It depends on how Zoom went. But if you're doing this via video, 1 through 18, blue slides, have questions, do the activity, fill it out. Tomorrow we dive into the sim system and do some more research. All right, have a great day, Bears. Let's do this.